Hello class, we're about to start section. It's supposed to be 3.12. It has 3.8 in your course pack, but it's supposed to be 3.12, and we're on page 238. Okay, it says 3.12 absolute value functions. To conclude this unit, we will look at one non-polynomial function, an absolute value function. Graphing absolute value functions. Fill in the table and then draw the graph of y equals f of x equals the absolute value of x by hand. Okay, so now what we're going to do, we're going to deal with the absolute value of x, y equals the absolute value of x. Now you only get two types of solutions when you're dealing with a straight absolute value. And I'm saying nothing is multiplied or added to it or taken to a power. If it's just an absolute value, and whatever you get the answer out of absolute value is either going to be positive or 0. So knowing that, this would be 5, 4, 3, 2, 1, 0, 1, 2, 3, 4, 5. Because all of these values here will either be positive or 0. Now we're going to graph this. We have 0, 0, negative 1, 1, 1, 1. Negative 2, 2, 2, 2, negative 3, 3, and then 3, 3, negative 4, 4, and 4, 4, negative 5, 5, and 5, 5. And we will connect these points, draw our arrowheads. And now, it says discuss the shape and characteristics of this graph, including the domain and range. Okay. Now, first of all, it's in a V shape. Okay, now they're talking about the characteristics of this graph. Now, if you look here, if you take a look here from 0, when it's equal distance from your initial point, which is 0 here, then what ends up happening is they end up having the same y value. Both of these x values are 1 unit away from 0, and both of their y values are 1. Negative 2 and 2 are 2 units away from 0, and both of their y values are 2. So basically what happens here is it has the same characteristics of a parabola. Because remember, with a parabola, once you find the vertex, and this would be considered the vertex, anything that's equal distance from the vertex will have the same y value, which we have here. Now, one other thing, we can also find the slope. Now, if you look here, now watch this. And I'm taking this as a line segment and a line segment. If you go to the left here, you go to the left 1. Well, let's do the rise over run. You rise 1 to the left 1. So that'll be 1 over negative 1, which is negative 1. You rise 1, you go to the left 1. Rise 1 to the left 1, rise 1 to the left 1, and so on. So we know this slope here would be negative 1. And then over here, you rise 1, go to the right 1 is 1. Rise 1 to the right 1 is 1, and so on. This side has its own slope of 1. So on the left side, the slope is negative 1. On the right side, the slope is positive 1. So what happens is you would get the slope, and the slope would be positive or negative, whatever that value is. Okay, now, the domain. The domain, if you notice here on a graph like this here, the domain would be from negative infinity to infinity. Now the range. The range actually can vary, but there are a couple characteristics that will stay consistent. On this graph, the range, if you notice here, one other thing. You have also a minimum point And then you can also, with other graphs we're going to encounter, you can also have a maximum point, just like those characteristics of a parabola. Now we know with the parabola the maximum or minimum point is the vertex, and it'd be the same thing here. Now the range has a couple restrictions here. One thing is we need to know for this problem here the range would be 0 to infinity. So the range basically goes like this. If you have a minimum point, then it'll be that point, that y value, to infinity. If you have a maximum point, then it will be that y, well, it'll be negative infinity to that y value, which we will cover in a few more problems here. So let's move on to page 239. Those were a few characteristics. Now it says use what you know about transformation of graphs to graph each of the following. Now remember our initial graph is f of x is equal to the absolute value of x. And we know our initial point is 0, 0. Now one other thing we need to know is this, well, that I need to show you all is this here. There was, when we were trying to find a vertex, remember this, we had f of x is equal to a times x minus h squared plus k. Now, and then our vertex or our initial point would be hk. Okay, now, for this problem here, what we would be looking for, and I'm running out of space here, so I'm going to write this here. We would be looking for f of x is equal to a times the absolute value of x minus h plus k. And it would give us the same effect of h and k would still be our initial point. Okay, so now we come here. Now we look here at our transformation. Now we know our initial point is 0, 0. We know that this point is going to narrow, or we could say stretch, and then it's going to go down 5. So if we here at 0, we will go down 5 to negative 5. And then now we can plot some points here. Now, we can do a few things here, and of course, it's up to you. Oh, one other thing that I forgot about. This A portion here is considered to be the slope as well. So the slope will be positive or negative 3. Okay, so now, knowing that, we know when we go to the left, it'll be negative 3. When we go to the right, it'll be positive 3. We can use this slope in order to find the other points. So here, let's go to the right. So we would go up 3, 1, 2, 3, and to the right 1. We will go up 3, 1, 2, 3, and to the right 1. We will go up 3, 1, 2, 3, and to the right 1. And we'll stop there. Now we come to the left side. You know, we will go up 3, 1, 2, 3, and then to the left 1. We will go up 3, 1, 2, 3, and to the left 1. Now, I know we could do this other point up 3 and to the left 1. But remember what I said about it having, the graph having the same characteristics as a parabola. Remember, parabola, when it's equal distance from the vertex, then that means they're supposed to have the same y value. So this is 3 away from the 0, 5, or 0, 3 away from 0, and then negative 3 is 3 away from 0. So then this should have a value of 4 for your y value, and we could prove that. We can go up 3 and then to the left 1, and we just proved it. Now we will graph these points here. So now we have a V-shaped graph. Now we look here at our domain. Our domain is negative infinity to infinity. Now our range, this is a minimum point. So our range is the the y value here, which would be negative 5. It'll be a bracket, and it'll go to infinity. Now we move on to the next problem. Now if we look here, we know we could do the slope. It'll be the slope, which will be positive or negative 1. We know it also reflects, because the a is negative. We know we would go to the right 2, and then up 4. So again, we would start at the initial point, which is 0, 0, from the f of x is equal to the absolute value of x. And it tells us here, what's important for us here is that we would go to the right 2 and then up 4 to get our initial point. Now, once we have our initial point, we do have our slope. So our slope tells us that we have positive or negative 1. So now, we could do this a couple ways. If we go down 1, that's negative, and to the left 1, that's also negative. So a negative and a negative makes a positive, so that would be our positive 1. Down 1 and to the left 1. Down 1 and to the left 1. Down 1 and to the left 1. And we could keep going. But let's go here for the negative 1. Down 1 and to the right 1. Down 1 and to the right 1. Down 1 and to the right 1. So we really didn't need to go down here to this negative 2. But now, we can connect these points. Now, our domain is still negative infinity to infinity. Our range, we have a maximum point. So that means we would go from negative infinity to our maximum y value, which is 4. And we'll put a bracket on the 4. Now, it says solve an equation containing an absolute value. It says to solve an absolute value equation, the absolute value of f of x equals c, you must solve the two related equations. One equation would be f of x is equal to c. The other equation would be f of x equals negative c. Now, we're going to translate that to our next page, which is page 240. Now we're going to solve each equation. Now, since we have our absolute value here, we add 3x minus 2 equals 10, and then we add 3x minus 2 equals negative 10. Now we will solve for x. We add 2 on both sides. 3x is equal to 12. We'll divide each side by 3, and x is 4. Now we go here to the next problem. We will add 2 on both sides. 3x is equal to negative 8. Divide each side by 3, and x is equal to a negative 8/3. Now we have to test and see if both of these work. So if we put in 4, 3 times 4 is 12 minus 2 is 10. Absolute value of 10 is 10, so we know x equals 4 work. Now we put in negative 8/3. These 3's will simplify out and leave negative 8 minus 2, which is negative 10, and the absolute value of negative 10 is 10. So it'll be x equals 4 or x equals negative 8/3. Now we go here to number 2. Now, one other key factor here is we must have the absolute value on the side by itself. It would actually make it a lot easier. So what we would do is add 2 to both sides. We add 3 times the absolute value of x is equal to 12. We'll divide each side by 3, and the absolute value of x is equal to 4. Now this will become x equals 4, and x equals negative 4. So now we need to test this. If we put in 4 here, well, let's look at this. 4 and negative 4. If you put in the absolute value, they're going to come out to be positive 4. 3 times 4 is 12 minus 2 is 10, and 10 is 10. So it's both of these here. Now we go here to problem number 3. So we had x squared minus 5x is equal to 6, and x squared minus 5x equals negative 6. So we'll subtract 6 on both sides. And x squared minus 5x minus 6 is 0. We'll add 6 on both sides. And x squared minus 5x plus 6 equals 0. Now we need to factor this. To factor this here, we will have x minus 6 and x plus 1 equals 0. And then we will set both of these equal to 0. And then we will end up with x equals 6 and x equals negative 1. Now we're going to test this in just a second, but let's take care of this other side here. When we factor this here, this will come out to be x minus 3 and x minus 2 equals 0. We'll set both of these values equal to 0. And then we have x equals 3. And then also x equals 2. Okay, so now, when we go back and substitute this in, all of these actually work. So this will be our final answer. Now we go here to problem number 4. We will subtract 7 on both sides. So we will have the absolute value of 5x is equal to negative 5. Now we can stop here because no matter what we put in this absolute value, it would not give us a negative 5. So your answer here is no solution. Okay, now we're going to go to page 241. Now we have a story problem here, or an application problem. It says, we will use the same technique as we used before. First it says solve inequalities containing absolute value. We will use the same technique as we used before. First, solve as if the inequality were really an equation. Place the zeros on the number line and check the inequality for test values in each section of the number line. So basically we're going to do truth tables. So we would treat this as if this is an equal sign. So we have absolute value of 2x plus 1 is equal to 9. So we know we had 2x plus 1 equals 9 and 2x plus 1 equals negative 9. Okay, so now we'll subtract 1 on both sides and 2x is equal to 8. We'll divide each side by 2 and x is 4. So we'll subtract 1 on both sides here and 2x equals negative 10. Divide each side by 2 and x is negative 5. Now that we have this, we have to look and see if the initial problem, if there was anything that could make this undefined. And we don't have any of those values. Typically that only happens when we have fractions. So now we would do our truth table. We will have negative 5 and also 4. Now again, we could try this. You could try this with your calculator as I talk you through this, or you could write it out and pause this video. But you're supposed to take a value here that's less than negative 5. I would try negative 6. If we put negative 6 in here, 2 times negative 6 is negative 12, plus 1 is negative 11. The absolute value of negative 11 is 11, and that's not less than 9, so this will be false. Now, negative 5 to 4, I will use 0. 2 times 0 is 0, plus 1 is 1. Absolute value of 1 is 1. 1 is less than 9, so this region is true. And last but not least, I will use a number higher than 4. I will use 5. Put in 5 here. This will be 10 plus 1 is 11. And we know the absolute value of 11 is greater than 9. So this is false. So our interval would be from negative 5 to 4. And they will be included. And that will be your answer for this problem. Oh, actually, it's not included. I'm sorry. I thought that had or equal to. So it's supposed to be a parenthesis. So it'd be parenthesis negative 5, 4. Okay, number 2. Now, we will add 7 on both sides. And we have 4 absolute value of x minus 2 is greater than or equal to 22. We'll divide each side by 4. and the absolute value of x minus 2 is greater than or equal to, we can divide both of these by 2, and it'll be 11 over 2. Now, we'll set this as if this was an equation. So it'd be the absolute value of x minus 2 is equal to 11 over 2. So we had x minus 2 is equal to 11 over 2, and x minus 2 is equal to a negative 11 over 2. So we would add 2 to both sides, and x will equal to, now this 2 can be rewritten as 4 over 2. 11 over 2 and 4 over 2 is 15 over 2. Now we will add 2 on both sides here, and x is equal to, this 2 can also be rewritten as 4 over 2. Negative 11 over 2 plus 4 over 2 is a negative 7 over 2. Now, since there's no fractions in this problem, nothing that would make it undefined, so now we will do our truth table. We will have negative 7 halves and 15 halves. Okay, now, for this, to the left of negative 7 over 2, I would just use negative 4 because we know negative 4 is really negative 8 over 2. So if we go up here and put in negative 4, negative 4 minus 2 is negative 6. Absolute value of negative 6 is 6. 4 times 6 is 24, minus 7 is 17. And 17 is greater than or equal to 15, so this region is true. For this region here, I will use 0. This will give us negative 2. Absolute value of negative 2 is 2. 4 times 2 is 8. Minus 7 is 1. And we know that's false because 1 is not greater than or equal to 15. And then 15 over 2 is the same as 7.5. So we could do 8. So I put in 8 here. 8 minus 2 is 6. Absolute value of 6 is 6. 4 times 6 is 24. Minus 7 is 17. And 17 is greater than 15. So that's true. So our interval will go from negative infinity to negative 7 halves. Be parenthesis in a bracket with the negative 7 halves. Union, it'll be 15 over 2 to infinity. Be bracket over the 15 over 2 and the infinity. And this will be your final answer here. Now we move on to page 242. Now on page 242, I actually said we had application problems on the last two problems we covered, but it's actually these two problems. And these two are the last problems. It says, in manufacturing, parts that are made have tolerance specifications, meaning that the part must be within certain size limits. These can be expressed using absolute value inequalities. A part's length specification is 3.8 centimeters with a tolerance of 0.001 centimeter. Write as an absolute value inequality and solve to give the range of acceptable lengths. So we will start this problem off as L minus 3.8, and L stands for the length, centimeters, must be less than or equal to 0.001 centimeters. And this would be our absolute value. Because whatever values that we put in for the length, we have to subtract 3.8, which is considered to be the specification, but it cannot be greater than 0.01 above that. So your length cannot be greater than or less than 0, well, it could be less than, but it can't be greater than 0.01. after it comes out of the absolute value. So we have L minus 3.8 centimeters, and we'll change this to an equal sign, equals 0.01 centimeters. So it'll be L minus 3.8, we could drop the centimeters for now, is equal to 0.001, and L minus 3.8 is equal to 0.001, or negative 0.001. We will add 3.8 to both sides, and L is equal to 3.801. Add 3.8 to both sides, and L is equal to 3.799. Okay. All right, so now there's no fraction here, so we don't have a value that would make this undefined. So we would do our truth table. Our truth table would be 3.779 and 3.801. Now, for values less than 3.779, since I have 3.8 here, why not we just use 2.8? 2.8 minus 3.8 would give us what, -1? And the absolute value of -1 is greater than this, so this would be false. Now in between here, 3.799 and 3.801, I will use 3.8. 3.8 minus 3.8 is 0, and 0 is less than that, so that'll be true. And last but not least, why not use 4.8? Since we got to pick a value greater than 3.801, 4.8 minus 3.8 is 1, and the absolute value of 1 is 1, and 1 is actually greater than that, so that'll be false. So now our interval would be 3.799 to 3.801, and it would be included. So that will be our answer. Now, it says here, in statistics, values that are more than 2 standard deviations away from the mean average are considered exceptional. In 2009, the mean ACT score was 21.1 with a standard deviation of 5.1. Write and solve an absolute value inequality to determine what ACT scores were statistically unusual in 2009. So we'll take the absolute value of A minus 21.1, absolute value, would be greater than or equal to 2 standard deviations. So it'd be 2 times the 5.1. Now, so we had A minus 21.1 is equal to 2 times 5.1. So it'd be A minus 21.1. And this right here will end up being 10.2. And then it'd be A minus 21.1, and it'd be a negative 10.2. Okay, now, we will add 21.1 to both sides, and A is equal to 31.3. We add 21.1 to both sides, and A is equal to 10.9. Now we would do our truth table. We add 10.9, 31.3. Now the value less than 10.9, I would just use 0. And then I would make this 21.1, and we know that would be greater than 10.2. So that would be true. And then in here, from 10.9 to 31.3, I would just use 21.1. 21.1 minus 21.1 is 0. And we know 0 is not greater than this value, so that'll be false. And then here, I will use what? 41.1. 41.1 minus 21.1 would be 20. And the absolute value of 20 is greater than 10.2, so that'll be true. So, our interval would go from negative infinity to 10.9. It'll be a bracket on the 10.9. Union will be bracket 31.3 to infinity. And this will be your final answer.